Let's start recording now. Yeah.
In question 3, the dyes of nitrogen of N2, the question 3, you put tricarbon in C2. Is there a reason why is that different?
You tell me, is there a reason?
Well, because you put tricarbon in C2, like as
Well, I know. Is there a reason? What do you think the reason is?
Is it because you switched them, or
Why did I switch them?
because of the charges?
Nope. This tri says there's 3 carbons. This di says there's 2 oxygens. What did I do? It's a good question. I made a stupid mistake and I swapped the numbers. If I've got work there, is there evidence to show that that was just a stupid mistake? Yes. I can now go back and fight for points. So let's fix that. You're absolutely correct. Right? So, which one do I want to tackle now? The first or the third or a fourth? I'm going to look at the fourth. Okay? I need to make sure that the 4 and the -1 cancel each other out. Okay? So, the way I teach it is doing a big fancy formula. We can simplify that and say they just have to cancel out. What's the lowest common multiple between 4 and 1? 4. What do I multiply 4 by to get 4? 1. What do I multiply 1 by to get 4? 4. Right? Do I need to specify the 1? No. If you specify the 1, are you wrong? No. Yes. Yeah, and that's mind-bogglingly stupid. Okay? Which will bring in the next issue with nomenclature. Nomenclature is a rule. If you break said rule, you are wrong. It doesn't matter if you're giving more information, you're still wrong. Okay? For instance, if I wrote lead acetate and then said uranium, 0. Does that change the identity of lead acetate? You're saying no, everybody else is saying yes. Why are you saying no? That's just saying uranium's not there, guys. There's nothing wrong with that. That is still lead acetate. Was it stupid to write that? Yeah, why? It's not wrong. It's extra information I didn't need. Okay? So they decided extra information that you don't need is by definition wrong. Lead acetate. Top one becomes the diciest of them all. Because when I go through, and we look at that one, we can now piece together our aspects on this. We've got Cr, which I remember as chromium. The oxygen, which we already addressed, we can get rid of the suffix and turn it into "ide." And I'd have chromium oxide. Except I have to remember that this is an ionic compound. So the amounts do not get explicitly stated in the name. That is only for molecular compounds. So in the ionic compound, what gets stated instead is the charge on our metal. Right? Are we required to memorize the charge on chromium? No. How do you know that? So it's not because it's in the equation. We can throw any metal we want into that. It's still in the equation. Okay? One argument that you will commonly hear is that it's a transition metal. True. Okay? Transition metals are a big red flag that you should be specifying the charge. Is zinc a transition metal? Yes. Is cadmium? Yes. Is silver? Yes. If you specify the charge for any of those 3, you are wrong. Okay? There are 3 transition metals that you have to memorize: zinc, cadmium, and silver. Group 1, Group 2, and aluminum are kind of easy to memorize their charges on based off of them trying to look like a noble gas. The transition metals are very challenging to deal with. Right? So you need to know Group 1, Group 2, aluminum, zinc, cadmium, silver. You got those memorized. If the metal's not one of those, you specify the charge. Okay, well, where's the charge specified? For those people looking at the periodic table, it's not useful. Where in the equation?
It's with the oxygen thing.
Say it again.
It's with the oxygen, the equation.
Okay. Charge is always written in the upper right-hand corner. Charge is for an individual unit. So the charge is specified for the molecule. It is not specified for chromium or oxygen. We do know that the overall charge must equal 0. Okay. I do know that there's 2 chromiums. Each of them are going to contribute charge. What is the charge on the chromium? Hell if I know. Or L if I know. That's what I said. Because now I am being recorded. Plus, how many oxygens? There's 3 oxygens. We have our amounts. What is the charge on oxygen? -2. For your 6, I'm going to bet what you went through in DED is said 3 times 2 was -6. Let's just say we did that. So cool. I have an equation with one variable. 2x equals +6. Doing the algebra really fast here. X equals 6 over 2, which equals 3. What did we say x was? And you tell me 3. I'm going to shush it. What did we say x was? There it is, the charge on chromium. Where do we specify the charge? Roman numeral 3. Okay. Recording is at 6 minutes, so I'm probably at like 10. Oof, I'm at 14. 14, but look at all the work and all the little pauses that we did in between. Okay? Kind of makes sense? Okay, with nomenclature, it's a challenge. Okay, and we already kind of addressed one of the issues behind a challenge. They are rules. You either know the rule or you don't. A lot of chemistry can be divined from balancing out charges and kind of putting it together. The absolute name for each of these is a rule. It is a definition. Well, how did you know that's chromium 3 oxide? Right? Well, why is my name Mike? I think that's a stupid question. It's a stupid question to ask you why that's chromium 3 oxide. Okay? The process behind how we got to the pieces that make that up, all of that work, yeah, that's good. Getting that absolute name is pretty useless. Okay? Those people wondering, like, that sounds kind of crazy for a chemist to say. Yeah, most chemists don't say that. Okay? Nomenclature is an absolute rule. You have to memorize the rule. You don't know the rule, you're done. Okay? How do you learn those rules? What's that? Practice. You can do tons of practice, and that will help you to memorize those rules. You could sit there and just stare at the rules and try and memorize them, but the practice is what's going to get you there first. Okay? And so you need an organization behind how you get to those names and how you get to those rules. Okay? There's a tutoring center here, right? Are you aware of that? Good. Heads shaking yes. Okay? Are the heads shaking yes just because you went there, or you just know that? Been there. Cool. Did you ask for the pink sheet? Yeah, the pink sheet, right? Pink sheet's pretty useful, huh? Has all the rules listed out and has a flow chart saying how to move through it so that you know which rule to use. Yeah, it's pretty awesome. You should go to the tutoring center if you're having problems with nomenclature, and you should ask for the pink sheet. Most of the tutors will look at you sideways, but then say nomenclature and they'll help you out. Okay? Tutoring center is an awesome resource. Take advantage of it. Okay? We good with nomenclature? Whole bunch of stuff. Write it all down. Right, why should you write it down? Another favorite story. You're going to get stories today. Got to fill the air with something. How many of you right now would be okay with everybody being able to hear what's going on inside your head? People laughed. Okay, they're like, nope, don't want that. Except when it comes to an exam, did you write your work down? Some people are like, yeah. The vast majority of people, where are you doing that work? In your head. That exact same place that you don't want other people to be is where you're doing all your work. You are literally taking a scary environment of the exam and you are making it scarier by doing it in your head. Write it freaking down. It's beautiful. You'll start writing it down and you'll be like, well, that's not how you spell beautiful. right? And you find out that mistake when it's written down. You do it in your head, you'll shuffle everything up. Write it down. It's not that early. I've got energy. Why don't you? I've been up since 6:30, so maybe that's it. We good? Okay. Random slideshow. So the next thing I heard was equations. So we might be doing this rapid fire kind of like jump through. Okay, so let's see what I can do. Tutor Center, we are talking about compounds, formulas, measurement. Oof, we got a lot to skip through there. If you see something you're like, wait, you can shout out too. Was that a wait? No. Balancing equations, okay? There's processes that you should be moving through to help out with it, right? Everybody's got slight deviations on balancing processes, right? The first thing that I would recommend that you pay attention to is that you need to look at that rule 1 and you got to make sure that you predict your products correctly. Not all equations do you have to predict products for, okay? But some you do. And if you predict the product wrong, the whole process goes sideways as far as balancing goes. Right? So make sure you predict your products correctly. How do we predict them? Well, we would need to know what type of reaction it was. Right? Because that's what's going to help us. Because you're only responsible for predicting products for some equations. In particular, single replacement, double replacement, neutralization, which is really just double replacement, and combustion. Right? Combustion's easy. You just produce CO2 and water. Right? Neutralization and double replacement, we're exchanging ions so that we balance those charges. You mean kind of like what we just did in nomenclature? Yeah, exactly what we just did in nomenclature. So if you've memorized that crossover rule for doing nomenclature, great, you figured out how to name. You got an answer for naming, but you just shafted the amount of work that you have to now do for balancing. Right? Shortcuts are a bad idea. Right? So follow that process and you can predict those products correctly. Once you've got your products correctly, that's where 2 comes in. Look at those formulas and make sure you actually drew them correctly. All too often I'll see mistakes in predicting the product, or you made a typo like I did, you called me out for, right? Yeah. Right? And swap some numbers around. Check your work and make sure that you've got those formulas correct before you start the balancing process. Then you can balance. Okay? Officially, any atom, you're good to go. Hydrogen, oxygen, generally not a good idea. Why not? It's a hard question. We got a rule for you. Like, why are we telling you not to balance hydrogen and oxygen? What might be the easiest answer to explain that? As a hint, we actually kind of addressed it already. First question you answer on the exam is? The easiest. Why might we tell you to not balance hydrogen and oxygen first? They're the hardest. Okay? So that's the easy answer to it with no chemical understanding. Hydrogen and oxygen are difficult to balance, typically. Why? Hydrogen and oxygen show up everywhere, okay? Which makes them difficult to balance because you don't know which hydrogen you should be changing. Okay? If you deal with the other elements first, hopefully the problem solves itself and you don't have to worry about balancing hydrogen and oxygen. That's why you leave them alone. Okay? If you have to take more chemistry, does anybody have to take more chemistry? Yeah, cool, a couple people. Okay, we're starting to get some activity. That's good, I like it. If you have to take more chemistry, you'll learn how to balance hydrogen and oxygen in a more advanced situation. Okay, multiple tiers of advancements. Okay, if you don't worry about it. We typically don't ask those questions. And now you'll go through and place whole numbers in front of your formulas. We don't change the formula because if we change the formula, the whole question changes. We've changed rule 1. So you only balance by changing the number in front. Okay? Then you go through and you repeat steps 3 and 4 until you've balanced all of your atoms. Cool. Then what do? You check your work. Okay? And note that I say you repeat those steps 3 through 5 multiple times. My general rule of thumb, how many times should you check your work? Those balanced. Well, how do you know it's balanced? You check your work. Right? That line, my rule of thumb is, you need to get mad. You need to get mad that Mike the sub came in and said, I have to check my work until I'm mad. And that guy's a jerk. When you get that mad, now you're good. You can move on. Just get a little bit of emotion in there, guess what happens? You remember. Okay? And if you remember, that's less effort for you to go through and memorize. Just get a little bit of emotion. Don't get so angry at me that you're going to be like, I'm going to intentionally fail this class. I don't want that. Just enough that you remember. Yeah? Okay, cool. And then verify smallest whole numbers possible. So cool. There we go. Do it. If you got questions, raise your hand. I'll come to you. I would argue it's not NO3. I would argue it's not the oxygen. Several of you already said it. The parentheses. Okay? Why the parentheses and not NO3? NO3 is an extra layer of thought on the inside. If your brain's good at it, great on you. Not everybody is. It's applying to what's directly in front of it. Directly in front of it is the parentheses. So whatever's in that parentheses gets multiplied by 3. Okay? Is the aluminum in those parentheses? No. So, Mike was wrong. How many aluminums are there? 1. Right? Now the trick. Those are not balanced, 2 and 1. Right? All too common what I'll see students go through and do. Hey, you found an imbalance, great. And then you move to barium. Okay? Or then you move to our sulfate or our nitrate. And you'll write all those numbers down. You found it was wrong to begin with, and what did you continue to do? Write more information. You know your very first premise is wrong. What's going to happen with everything afterwards? It's also going to be wrong. As soon as you find an imbalance, fix the imbalance. Don't continue to write stuff down. Okay? Another form for work. We could say aluminum, there's 2. Why is this red aluminum being written way over here? Maybe it helps if we show where the other aluminum should be written. You're showing to each side of the equation. Nothing wrong with that work. Okay? None of you are standing up. Why not? Why not? It's comfortable. Okay. You're inherently lazy and you want to sit down. If we gave you the opportunity to sit in recliners, what would you probably do? Yeah, there we go. Honesty in the back. Yep, I would sit back and recline. I might even go to sleep. Okay? We're inherently lazy people, and yet what are you doing by writing it out like this? You're writing it twice. That's not lazy. You're gung-ho and you want to write a whole bunch. Limit the amount of writing you do so that when you write, you're writing facts and you minimize your mistakes. Okay? If this notation you're happy with, you like it, stick with it. By writing it underneath the arrow, I don't have to rewrite aluminum and an extra arrow. I can just write the numbers next to it. Make sense? Okay. Both methods work. I just want to address some of those subtle differences. Okay, so aluminum's not balanced, so I don't care about anything below it. Okay? So now the question is, how do we balance it? Okay? If my hands were part of a balance, right, it would be like this, because the iPad weighs more than the pen. Okay? How could I balance this and make sure my hands evened out? I could add more pens. I don't have that many pens that fast, so just pretend. What else could I do? Sorry for people at home with the recording. right? What did I do? I got rid of weight. So there are two ways to balance. We can get rid of weight or we can add weight. Can we get rid of weight in an equation? No, you can only add. Right? So it's just a feature of how we balance in chemistry, slightly different from the outside world. So now the next part, how do we do it? I'll get some people saying, well, I add 1. It's not that that statement is wrong, but those words that you're using implies a different mathematical procedure than we want. The only number we can change is the number out front. And the operator that sits in there, mathematical operator, is what? Multiplication. So it's not that I want to add 1 aluminum. It's that I want to turn that 1 into a 2 by multiplying by 2. How do I do that? I put the 2 there. This now becomes 2. Make sense? So now we could jump to the barium, right? Which I would agree with personally. I think that's a good choice. But why did we not look at the sulfate? Why would you do barium instead of sulfate?
Barium's ionic.
Say that again?
Barium's ionic.
So sulfate, so I don't quite accept that. Oxygen, okay, that's fair. One's complex, one's simple. Okay, pick with the simple ones first and hope you don't have to worry about the complex. It's a good option. Okay, so barium on the left, how much do we have? 1, because the 2 applies to the parentheses. Wow, fast learners, I like it. On the right, how many do we have? I heard 4. What's directly in front of the 4? The oxygen. Not sulfate, oxygen. That's going to become important in a second. Okay? So that 4 only applies to the oxygen. It does not apply to the barium, which means how many bariums? 1. Okay? Now we do have to dive into either our sulfate, nitrate, sulfur, or oxygen. Okay? And how do we do that? So, not calling anybody out, so don't stress. I saw SO written down. Okay? Yes, we see SO written up there. Okay? You saw AL, right? Why'd you not write just A? A and L are required to be aluminum. They're together. When we're looking at this, this is aluminum with what? I don't even care about the amounts. I just want to know what this is. What's the aluminum balanced with? Sulfate. What is sulfate? An ionic compound with the formula SO4. You get rid of the 4, is it sulfate? No. So if you're going to balance, which I think is what the attempt was being made to do, balance sulfate, that 4 is part of the name, just like the L was part of what made that aluminum. So I'm not balancing SO, I'm balancing SO4. Okay. What's on the left side? How many sulfates do I have on the left side of the equation? Okay, so the first thing we could do is identify our sulfate, SO4. All of those things are what make it sulfate. How many times do those show up? 3. And that's because this parenthetical means 3. Okay? That can be challenging to nuance, so we could write it out this way. Whoops. That's what that formula means. 2 aluminums, 3 SO4s. Okay? So, 3 sulfates. How many on the whatever the other side of the equation is. That would be the right. 4, right? Because I see a 4. No, good. Defense. This is where, if multiple colors are there, that's what makes sulfate. How many times does SO4 show up? Once. Are those balanced? What do you need to do? Multiply by? Where do I put the 3? I have to put it in front. If I put it as a subscript, I'm now changing the formula, and I can't do that when balancing the equation. Balancing the equation, the only thing you are allowed to touch is that coefficient in front. Are your sulfates now balanced? So now what can we do? Okay. Now we could tackle the nitrate, NO3. Again, that 3 is what makes it nitrate. So that 3 is part of it. How many times does NO3 show up? Shows up twice. I undermeant what you stood. Thank you for the courtesy laugh. It was appreciated. For those that did. The nitrate on the right shows up 3 times. How do you make 2 equal to 3? What's that? Find the least common multiple. How do we find the least common multiple? You can multiply them together. What's the least common multiple of 4 and 2? 8? 4. So it's not just multiplying by each other. Recognize it has to be that smallest, lowest common multiple. Right? And I get a sneaking suspicion that I goofed a number somewhere in here. 6, 2, so those come out. How do we make that a 6? We had to multiply by 3. We had to multiply by 2. Yeah? Did we change any numbers in the process of balancing? So that number didn't change, right? I agree with you. Cool. Did that number change? Yes. Did we change numbers? Yes. What do you need to do? Step 5. Check your work. How many aluminums on the left? 2. Oh, I didn't put that 2 in there last time, did I? I erased that. How many on the right? That was an eraser. How many sulfates on the left? Good eyes. 3 on the right. How many bariums? How many bariums? That 3 applies afterwards. Since the barium is after it, there's 3 on the left, on the right. How many nitrates? This gets fun. Let's take a look at this. BaNO3. How many NO3s are there? How many times does this show up? Everybody get that?
I'm a little confused on the variant. I don't know why. I have ones for stuff I'm writing up.
So what that's going to mean is the work that we went through, you missed one of the cases where we put a number in. We had ones initially, but that became a 3 and a 2. When? When we balanced the nitrates. Because the nitrates, to get even on both sides, we had to find that lowest common multiple of 6. So that means we had to change the coefficient in front of that whole expression that contained the nitrate. On the right-hand side, how many nitrates do we have? Same deal, except kind of inverted. We have 3 in the individual formula, but I'm running it twice. We get 6. Is it balanced? Yes, so what do we do? Hey, cool. Check your work. You erase it all, you do it again. Okay? Generally, when you go through and you don't touch the numbers, you're probably good to stop. If you haven't changed any numbers, you don't have to check your work again. Okay? There were a couple hands I saw. Yours first, then we'll go back to you.
So okay, wait, this might be a dumb question, but for what is it,
Sulfate.
sulfate oxide, so I just separated the S and the O when I did the whole thing, and then that nitrogen as well, and I got the same answer.
Yes.
Is it just like the longer way, or did I just get lucky? Or?
So when we go through and balance, officially what we're balancing out is the elements on both sides, because we can't destroy elements. Can you destroy complex ions? Yes, you can. Right? So the process that we did by balancing with the complex ion, we can't always do. When are we allowed to balance with sulfate and nitrate? Does it get destroyed in the process of this reaction? If it's not destroyed, I can balance as sulfate. It's now just a larger piece. If it gets destroyed, then I have to balance by atoms. It is a choice to balance atoms or larger pieces. Okay? And as long as the piece does not get destroyed in the process of the reaction, you can balance by that piece. So it's up to you to decide your comfort level. If you're more comfortable by going atomic, do atomic. If you're more comfortable by looking at those pieces, look at the pieces. Generally, most people seem to be happier with pieces once you acknowledge what those pieces are. That's a cognitive leap that you'd have to clear. If you don't want to clear it, don't worry about it. Go atomic and you don't have to stress.
Is it harder to put the one in front of the aluminum?
Specifying a 1 here. So that nomenclature thing where we talked about if you put in parentheses the wrong information, you're wrong. I have not heard of a rule saying it's bad to put the 1 in. Okay? And the nomenclature one I learned when I first started working here. 10 years of chemistry, I'd never heard that that was an issue with nomenclature until someone was like, no, you put parentheses when you're not supposed to put parentheses. You're wrong. That's stupid. Okay? I've never heard of anyone complaining about that. And I would argue it is probably better to write it in. Because one of the most common ways to ask about balancing equations, particularly in a multiple choice format, is what is the sum of the coefficients. So we give you a balanced equation, we say balance it. If we then say which of these is the balanced equation, you could kind of process of elimination your way through. So instead what we do is say what's the sum of the coefficients, and now we just list a sequence of numbers. Right? You have to match up the right number. Right? So what would the sum of the coefficients be? Well, the coefficient was the number in front. So we go through, I have that 3, I have that 2, I see a 3, I add that up, and what do I get? 8. Guess what? 8 shows up as a multiple choice answer. And we're wrong. Because we didn't see the implied 1, so we didn't add it to our total, and therefore we got the answer wrong. Sneaky. Okay? Which means, if you think you want to avoid that mistake, always include those 1s. So when you get that question, sum of the coefficients, you don't fall for the 8 trap and you get 9. Make sense? Good question. How are we doing? What time is it? We're done. Sorry. Right? No? 45. Okay, never mind. We can keep going. Lucky you. What next? More balancing?
Yeah, let's do some more balance.
Yep. Let's clear it. Whoop. Give me some more balancing. You're shaking your head, which means, of course, we should do this one.
That's easy.
Is it? Did I do an easy one? Okay, well then balance it. How many carbons on the left? 4 carbons on the right. 1. So they don't balance. How do we get, where's our lowest common multiple between 4 and 1? 4. What do we multiply 4 by to get 4? 1. So we could, following your advice, put that 1 out front. That's fair. What do we multiply 1 by to get 4? 4, put the 4 out front. Yeah? Cool, then what do we balance? Hydrogen. How many hydrogens on the left? 10. But we multiplied by 1. Still 10. Okay, just checking. Just checking for those people in the back sitting in that lazy chair going to sleep. How many hydrogens do we have on the right? 2. Is 2 equal to 10? That's no. 2 does not equal 10. Any level. How do we make 2 equal to 10? We multiply by 5. So if we're multiplying by 5, that's what gets us our 10. We do that by putting a 5 there. Yeah? Cool. Now what do we do? Oxygen. How many oxygens on the left? 2. Oxygens on the right? 3? That 4 applies after. That 5 applies after. So, yeah, slow down. I'm trying to figure out what I want to write. So we had 2 oxygens, but there's 4, right? Plus, we had 1 oxygen, but there's 5 times that shows up. So we get 8 plus 5, which equals 13. Yeah? Did you say no? Did I not do that right? Oh. Yeah, stop skipping. Taking all the thunder away. How do I get 2 equal to 13? All right, we said we can only balance with whole numbers, and there's no way you can get 2 equal to 13 with whole numbers. Right? So what would the not whole number be? What would I multiply 2 by to get 13? 6.5 is one way to do it. Or we could do 13 over 2, which is 6.5 for the record. I'm not saying that's not. But by writing it as that fraction, does that help us to see that those 2's would cancel and we'd have 13? Yes? That's all I need to see here. Yes. Yeah, okay. So then we could write 13 over 2, because we multiplied by 13 over 2. Yeah? Yeah, same pattern. Am I allowed to do that? Why not? It's not a whole number. Right? So now we encounter an issue. How do we fix this? Right? Well, one approach is exactly as we did here. Right? We multiply by the fraction and we say it's not a whole number. How do I make 13 over 2 a whole number? How do I get rid of that 2? Multiply it by 2. How does that change our expression? What is 2 times 1? What is 2 times 13 halves? 2 times 13 halves is 13. We'll get to your 26 in a bit. 2 times 4, 8. 2 times 5, 10. And with those kind of numbers, there's no way this could possibly balance, right? Carbon, how many carbons on the left?
8.
There's 2 and the 4, 8 on the right. Straight up 8. This is looking kind of suspicious. Hydrogen on the left. There's 2 and the 10, so we got 20. We got the 10 and the 2, we got 20. Oxygen. 13 times 2 is our 26. 8 times 2 is 16 plus 10, 26. Wow. That's kind of neat. The other method, which I think is constant, because I think you all were doing it and I've never actually seen it done this way. So I didn't acknowledge it when you were telling me. Let's try it. 4 and 4. Hydrogen, we said was what, 10 and 10. We had 2, what was the other number? 18? 13. Lowest common, oh my gosh, I can't believe I've never saw this. That's stupid. What's the lowest common multiple between 2 and 13? How do you make 2 to 26? Times by 13. How do you make 13 into 26? Times by 2. Okay? But there's where the issue is. Yes, your timing's by 2, but what are you timing by 2? Which one? This is why oxygen becomes tricky. Which one are you timing by 2? You're timing them both. And that's why that method of finding the lowest common multiplier for those gets on shaky ground, because it's oxygen showing up in 2 different places. Okay? So that's why I would argue the other method that I went through and showed is a little bit cleaner. You could argue that if you're multiplying by 2, you need to multiply both of these by 2, which would mean 8 and 10. Is your equation balanced? No, so what do? We erase all of our work and we try again with those numbers. Make sense? Then we'd recognize we have to adjust the carbon and all that. And now I'm going to guess we're at time. So I will go ahead and stop the video.